Get ready to navigate through mind-blowing facts about your compass. That trusty tool you've been using for directions. Did you know that its needle has actually been pointing a different direction over the past 2,000 years? That's right, it's like having a personal GPS with a bad memory. From ancient explorers to modern-day map apps from Google and Apple, the constant need to update their maps is no joke. But have you ever wondered what will happen in 10,000 years? Will we still be able to find our way using this old-school technology? Let's dive into the fascinating world of magnetic fields and discover why your compass isn't as reliable as you thought. Let's go back to ancient China, around 2,000 years ago. That's when our journey with the trusty compass begins. The first ever compass was created during this time period, and as people started using it for navigation, they discovered something amazing. Its magnetic needle always pointed in a consistent direction. Fast forward to today, and you'd think everyone knows where that direction is. But here's the question. If someone with no idea about geography asked you, where does the compass point? Would you answer, North Pole? You might be surprised to know many people actually do. So you think your compass always points directly to the North Pole? Think again. What you're actually seeing is the compass needle being drawn to the magnetic North Pole, which isn't even in the same spot as the geographic North Pole, our planet's actual northernmost point. The difference between these two norths is staggering. The magnetic North Pole is drifting over land by hundreds of kilometers, and its location inside Earth changes all the time. So what's causing this magnetic mystery? That's the next stop on our adventure. Let's find out. Get ready for a journey to the heart of our planet, literally. You've got your crust on top. Then comes the thick layer of molten rock called the mantle. But what's down at the very center? That would be Earth's core. It's divided into two parts: a super hot, iron-rich inner core that's as solid as steel and an outer layer that's just molten lava. With temperatures soaring in this underground ocean and intense pressure reaching 2 million atmospheres, things are really heating up. But here's the amazing part. The molten iron and nickel inside our planet is constantly on the move due to convective flows. It's like a cosmic soup with iron at its core, swirling around the solid inner core. Here's the cool part. Our planet's core in motion is the reason we've got this amazing shield, our magnetic field. It stretches way out into space, about 70,000 kilometers deep, and keeps us safe from harm caused by solar winds and other cosmic radiation that could cause chaos on Earth. This powerful force even helped humans invent a game-changing tool, the compass. And guess what? The Earth's magnetosphere has its own axis, just like our planet, which is pretty mind-blowing when you think about it. Now let's talk about our planet's magnetic axis. It's got two poles, and they're called the North Magnetic Pole and the South Magnetic Pole. The cool thing about a compass is that its needle always points towards the North Magnetic Pole. But here's something you might find surprising. The magnetic poles aren't actually located where you'd expect them to be. Normally, we'd think of the North Pole being in the north and the South Pole being in the south, but in our case, it's a bit mixed up. The magnetic field has decided to play it differently. Right now, the spot that acts as our North Magnetic Pole is actually located deep within the Arctic Ocean, in the northern hemisphere. So you're wondering what happens if a brave traveler follows their compass northwards. Well, it's not as simple as reaching the geographical North Pole. You see, in some parts of our world, your trusty compass needle might point slightly east or west instead of directly at the North Pole. This happens because of something called magnetic declination, the difference between the actual geographic north and where your compass is pointing. It's like having a slight detour before reaching your destination. In fact, this wasn't always understood. Way back in the 11th century, Chinese astronomer Shen Kuo noticed that his compass didn't always point to true north. This discovery led sailors and travelers to use more accurate maps that took into account this magnetic twist. Then, over a century later, English mathematician Henry Gallibrand cracked another mystery. He found out that the location of our planet's North Magnetic Pole actually changes. So if you're planning an adventure, make sure to check those navigation charts for any compass corrections before you set off. You might be surprised to learn that we've known the exact spot where our planet's North Magnetic Pole is located since 1831. It was way up north on Cape Adelaide Regina in the Canadian Arctic. But here's the thing, this magnetic pole doesn't stay put for long. By 1904, another team of explorers found out it had moved several tens of kilometers north. Since then, 5 more expeditions have gone searching for this elusive North Magnetic Pole, and each time they've discovered a new location. What's even more fascinating is that the magnetic pole has been hanging around Canada for about 400 years, but who knows where it will be tomorrow. It just goes to show how dynamic our planet can be. So keep your compasses sharp, explorers. Get this, our planet's magnetic field axis is actually moving faster than ever before. Just to give you an idea, in 2007, the spot where your compass needle points was a whopping 700 kilometers away from the actual geographic North Pole. But fast forward to 2019, and it had shrunk down to only about 390 kilometers away. That's some serious shifting going on. And here's the craziest part. Our magnetic North Pole is currently zooming towards Siberia at an astonishing speed of 50 kilometers per year, which breaks down to over 130, 6 meters or 440, 6 feet every single day. Whoa, time to update those maps and compasses, explorers. You might wonder why Canadians are freaking out about this magnetic pole shift. It's because for centuries, they've been calling the North Pole their own. But in a major blow, in 2005, Canada lost its grip on magnetic north when it officially moved beyond the country's territorial waters. Today, no one knows exactly where it will end up, as scientists still can't crack the code to predict how the Earth's molten outer core is behaving. We're talking about the speed, intensity, and direction of massive flows deep within our planet. So, buckle up, folks, because this magnetic mystery is far from over. Now we're getting into the nitty-gritty of what's causing our magnetic North Pole to make a break for it. So, imagine you've got a giant whirlpool of liquid iron inside Earth. That's basically its outer core in action. As our planet spins around its axis, this swirling mess gets twisted and turned, kind of like when you spin a sticky note and it curls up into a corkscrew shape. Scientists are working on simulating these deep Earth currents using supercomputers to better understand what's going on. The Earth's magnetic field has been changing in all sorts of ways over billions of years. Flip-flopping polarity, getting weaker, you name it. Right now, it looks like our wandering North Pole is heading east towards Siberia and might just touch down by 2050. Let's talk about a potential new address for our North Magnetic Pole. And it's not Canada anymore. If things stay on track, by 2050, this wandering pole might end up on Russian soil, specifically on the Taimyr Peninsula. Now, you're probably wondering what's happening with its southerly counterpart. Well, the South Magnetic Pole is also on the move, but at a much slower pace. Scientists are still trying to figure out why the South Pole seems more stable than the North, and one theory has something to do with the landmasses in each hemisphere. It turns out that the bigger the continents in a given half of our planet, the more likely it is for its magnetic field to flip-flop direction. Here's the deal. If our continents were perfectly balanced around the equator, Earth's magnetic field might stay steady for millions of years. But since they aren't, we're dealing with a moving target when it comes to our planet's magnetic axis. This rapid shift is causing some serious headaches in the space and transportation industries. Just think about all the runways at airports that use magnetic azimuth markers. These numbers are now outdated and need an update. Navigation systems also have to adapt to this change, making our reliance on technology even more complex. You're probably wondering what companies like Apple and Google are doing to tackle this issue. They're updating their mapping apps to give you the most accurate directions possible. But here's a bigger picture. Earth has been through something called a magnetic inversion or pole reversal, where the North Pole becomes the South Pole, and vice versa. This hasn't happened overnight. It's actually occurred about 100 times over the past 160 million years. Right now, our planet's magnetic field is getting weaker by the day, and scientists are keeping a close eye on this natural phenomenon to see what it might mean for our future. The Earth's magnetic strength is dropping by about 5% every century, a clear signal that scientists think another pole reversal might be on its way. But before you worry, let's break down what this means for our planet. Researchers using the European Space Agency's Cluster 2 satellite system discovered that when our magnetosphere weakens, it actually starts to blast oxygen ions into space. Now, if the weakening continues, this could cause a tiny increase in the amount of oxygen in our atmosphere, and while that might not sound like a big deal, even small changes can have surprising effects on our environment. With science advancing at lightning speed, we've got nothing to worry about. Humanity will undoubtedly find ways to adapt to whatever changes come our magnetic pole's way. But let's keep things in perspective. Your trusty compass isn't giving you the exact location of the geographic North Pole. It's just a rough guide for finding those cardinal directions. That being said, don't ditch your compass on that next hike. Its margin of error is still super small, and it'll definitely help you stay on track. Now that we've got a better grip on how our compasses really work, let's think big-o. Where will the North Pole be in 10,000 years? And by then, will we still be relying on trusty old compasses to navigate? The possibilities are endless, and we want to hear your thoughts.